Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel and like all my videos if they are helping you. Now I am going to solve this particular problem. This problem is based on 3D equilibrium problems, that is the 3D equilibrium topic, right? So I will tell you people, I will solve this problem with a smarter way, right? So on YouTube you people will see that some people will solve it by finding the moment about this point A and then having 4 to 5 equations, and then some of them are solved simultaneously, right? So that makes this problem a bit complex, right? So I will tell you people a very smart way of solving this particular problem, right? So now in this particular problem we have this sign board which has a mass of 100 kg with a center of mass at this point G, and we are required to determine the x, y and z components of reactions at the ball and socket joint A and tensions in wire BC and BD, right? So let's say that we have this tension in this wire, right? Let's say that this is TBD, and here this is the tension in this wire, and this is, let's say, TBC, right? And we are required to determine the reactions at this ball and socket joint, right? So let's say that here we have AX reaction which is acting in the x direction, that is in the negative x direction. Here we will have AY reaction that is acting in the positive y direction, like this. Let's say this is AY, and let's say that we are having reaction in the positive z direction, like this. Let's say this is AZ. So we are required to find the magnitudes of AX, AY and AZ, and we are required to find the magnitudes of this TBC tension and this TBD tension, right? So now first what I will do is that I will write this TBD, TBC and the weight of this sign board. Let me represent the weight of this sign board as well, right? So the weight of this sign board will be acting vertically downward, right? And this has a mass of 100 grams, so 100 times 9.81, so this is 981 Newton, right? So I will write that this weight is 981 newtons and it is acting vertically downward. So now what we will do is that we will represent this TBC, TBD and this weight as a Cartesian vectors, right? So let me write that. First I will write the total reaction at this ball and socket joint, right? So we can write that A vector, Cartesian vector, will be equal to AXI, right? This AX is acting in the negative y direction, so let me write that this is minus AX, right? And then we will have plus AYJ plus AZK, right? Similarly I will write that weight as well, right? So let me write that weight vector. So weight is only acting in the negative z direction, right? So this means that it is 0I plus 0J minus 981K, right? So it is acting in the negative z direction. Similarly I will write TBC, right? So to write TBC vector, so this will be equal to TBC magnitude times the unit vector along BC, right? Or we can write this unit vector as RBC, the position vector, divided by the RBC magnitude, right? So we have to find this unit vector, first this position vector and then the magnitude of that position vector. So how to find this position vector? For that first we need to have the coordinates of this point A, B, C and D, right? So the coordinates of point A are 0, 0, 0, since this is the origin. The coordinates of point B, right? So the coordinates of point B are, to reach this point B from that origin we need to travel 2 meters in the positive y direction, right? So I will write 2, and since this point B is lying on the y axis, so there is no need to travel in the x direction, and there is no need to travel in the z direction, right? So the coordinates of this point B is 0, 2, 0. Similarly the coordinates of this point C, right? So to reach this point C from the origin we need to travel 2 meters along z. So I will write 2 meters along z, then 1 meter along positive x, and there is no need to travel in the y direction since this point C is lying in the xz plane, right? So this is 1, 0, 2. Similarly, to find the coordinates of this point D, we need to travel 2 meters in the negative x, so I will write -2, then 1 meter in the positive z, and this D point is lying in the xz plane again, so the y coordinate will be 0. There is no need to travel in the y direction, right? So these are the coordinates of point A, B, C, D. So we can write TBC vector. So TBC, I can write this as TBC and RBC vector, right? So to find RBC, we need to subtract the coordinates of B from C, right? So this will be 1 minus 0. So I will write 1 minus 0 I, right? And 0 minus 2j. So I will write plus 0 minus 2j, and then 2 minus 0k, right? So I will write plus 2 minus 0k. Right, so we can simplify this. 1 minus 0 is 1, so we will be left with 1i minus 2j and plus 2k. Right, so we are left with this. So the magnitude of this is 1 square plus 2 square plus 2 square. And when we simplify this, so this magnitude comes out to be as 3, right? So this is 3. So we can write this TBC vector. So let me write TBC vector. So this will be TBC magnitude. So this will be 1 divided by 3i, 1 divided by 3i, minus 2 divided by 3j, and this is plus 2 divided by 3k. Right, so this is the TBC vector. Now I will find TBD vector in the same way, right? So I will write TBD, and then we will have a TBD magnitude, and then the unit vector along BD, right? And the unit vector along BD will be RBD divided by the magnitude of that position vector, right? So I will write this as TBD. And now what we will do is that we will subtract the coordinates of B from D, right? The corresponding coordinates of B from D, right? So this is minus 2 minus 0. This is minus 2 minus 0 is minus 2. So I will write minus 2i. 0 minus 2. So this is minus 2j. And 1 minus 0. So this is 1 minus 0 is 1k, right? So I will write plus k. And this, the magnitude will be 2 square minus 2 square. So minus 2 square or plus 2 square is same thing. Minus 2 square and plus 1 square. Right. So this is we can write it like this. Right. And again, this magnitude is 3. This is 3. So I will write that this is 3. So we can write this in simplified form. So TBD. Let me write that TBD vector, Cartesian vector, is equal to TBD magnitude, and this is minus 2 divided by 3 I, minus 2 divided by 3j, and plus 1 divided by 3k. Right, so this is TBC vector, this is TBD vector, this is A vector, and this is W vector, right? Now what normally people do is that they find the moment about point A, and then they apply this equation, the summation of moment about point A equals to 0, and then they have three equations, right? And then they need to solve those equations as simultaneous equation, right? But what I will do to solve this problem in a smarter way, what I will do is that I will apply the summation of moment about point B equals to 0. Right, since as we can see that this TBD force and this TBC force, they are passing to that point D, that point B, so they will not produce the moment about that point B, right? So that will make our life easier, right? And that will give us some of the components of this reaction at point A, right? So if we find the summation of moment about point B, so then we can apply this equation like this. So we will write that the moment arm for these reactions will be from B to A, right? Let me represent that moment arm, right? So this will be the moment arm for those reactions, right? Let me write that this is RBA position vector. So I can write this equation as RBA cross A vector plus if I extend the line of action of this 981, this weight, right, so it will intersect somewhere here, right. So we can define the moment arm for this weight as a RBG vector. Let me represent that RBG vector. So that RBG vector will be from B to this point, right. Let's say that this point is, let's say, G dash, right. So we can write that that RBG dash cross weight. The moment arm could be the a position vector from point B to any point on the line of action of this weight, right. So we can define this RBG dash since it's easy to find, right. So now we can find that RBA position vector. So RBA position vector. So we need to travel the coordinates of B from A, right. So the coordinates of A are 0, 0, 0, right. So 0 minus 0, this is 0 I, right, and then this is 0 minus 2, so this is minus 2 j, and 0 minus 0, so this is minus 0 k, right. So this is the position vector from B to A. Similarly, the position vector from B to G dash. So first we need to find the coordinates of G dash, right. So G dash, right. So as we can see that to reach this G dash we need to travel 1 meters in the positive y direction, right. So this is 1, and there is no need to travel along x, and there is no need to travel along z, right, since this G dash is lying on the y axis, is right. So to find this RBG dash, what we need to do is that we need to subtract the coordinates of B from G dash, right. So this is 0 minus 0, so 0 I, and 1 minus 2, so this is minus 1 j, right, and 0 minus 0, so this is minus 0 k, right. So we have these moment arms for A vector and W vector, right, and this will be equal to 0, right. So now I will write them in determinant form. So RBA is 0 minus 2, and this is 0, right. You can write this is plus, right, there is no need to write minus. So this is 0 minus 2, 0, and this is AX, AY, and this is AZ, right. Similarly, RBG dash, so I, J, and K, and RBG dash is 0, minus 1, and this is 0, and weight is 0, this is 0, 0, and minus 981, and this will be equal to 0, right. So now to find this determinant, this will be minus 2AZ minus 0 into I, right. So this is minus 2AZI. Similarly, this is 0 into 0, so 0J, and then this is 0AY, and this is plus 2AX, right. So I will write plus 2AX into K, right. Similarly, we can write, so this is minus into minus 981, so this is plus 981 I, plus 981 minus 0, so this is 981 I, and then this is 0 and 0, 0j, and this is 0 into 0k, right. So this will be equal to 0. So this equation gave us very simple equation, right. So I can write that this is minus 2AZ plus 981 into I, and plus 2AX k equals to 0, right. So this will be equal to 0 since here we have 0I plus 0j plus 0k vector, right. So the I term is equal to 0 and the k term is equal to 0, right. So from this we can write that minus 2AZ plus 981, this is equal to 0, or we can say that AZ equals to minus 981 divided by minus 2. So if we divide this, so this will give us 490.5, right. So AZ reaction is 490.5 newtons, right. And similarly we can write that 2AX is equal to 0. So from this we get as AX equals to 0. So now we can update our A equation, right. So our A equation is, we can write that this is AX So ax is 0I, right, plus ayj, and this is plus 490.5 k, right? So now we can write this updated equation here, right? So this will be minus 0I, this is ayj, and this will become 490.5, right? So this is 490.5. Let me write 490.5 k, right? So this is our updated A equation. We have found Ax and Az, right? Now if I apply the summation of forces along x equals to 0, so what we will do is that we will add all the I components of the Cartesian vectors, right? So this is 0, so I will write 0, and the weight I component is also 0, this is 0 plus 0, and then we will have 1 by 3 TBC, right? So I will write plus 1 divided by 3 TBC, and then we have minus 2 divided by 3 TBD, right? So this will be equal to 0. So from this we can say that we have this equation, we can multiply this whole equation with 3, so we will get this equation. So from this we can write that TBC equals to 2 TBD, right? Let me write it here, that TBC equals to 2 TBD, right? So we have this very important equation, right? So let's say this is equation 1. Now if I apply the summation of forces along z equals to 0, so for this we will add all the k components, right? So here we have 490.5, so I will write 490.5 minus 981, and then this is plus 2 divided by 3 2bc, so I will write plus 2 divided by 3 tbc. So I will replace the TBC by 2 TBD, right? So 2 TBC is TBC is 2 TBD, right? This is TBC, and then we have 1 divided by 3, right? So I will write plus 1 divided by 3 TBD, and this is equal to 0, right? So this will become, we can write that this is 4 divided by 3 TBD plus 1 divided by 3 TBD, and if we bring this to the other side of equation, so this will be 981 minus 490.5, so this will give us plus 490.5, right? So this is 490.5 newtons, and if we add this, so this will be 5 divided by 3 TBD, right? So I can write that this is 5 divided by 3, and if I multiply both sides with 3 divided by 5, so this will give us TBD. So this is 490.5 into 3 divided by 5. So this gives us 294.3, right? So TBD is 294.3 newtons, right? And now as we know from this equation that TBC is 2 times 2BD, so I will multiply this with 2, so that will be TBC magnitude, right? So TBC equals to 2 times, right? So we will multiply this answer with 2. So this is 588.6, so this is approximately 589, right? So I will write this as 589 newtons. So this is the TBC. And now we are left with AY. We need to find this AY. So what I will do is that I will apply the summation of forces along y equals to 0. So then we will write this AY plus this 0, right? And then plus minus 2 by 3 TBC. So I will write minus 2 divided by 3, and TBC magnitude is now known, which is 589, right? So I will write this as 589, and then we will have minus 2 divided by 3 TBD, right? So I will write minus 2 divided by 3, and TBD magnitude is now known, which is 294.3. We can say that this is approximately 294, right? So this is 294. So this will be equal to 0, right? So from this, if I bring these two to the other side of equation, so they will become positive. So AY will be equal to this thing. So we can write that 2 divided by 3 multiply by 589 plus 2 divided by 3 multiply by 294. Right, so this is equal to again approximately 589, right? So AY is equal to 589 Newton. Right, so the X, Y and Z components of the reactions at ball and socket joint are 0, 589 Newton and 490.5 Newton, and the tension in TBC wire is 589 and the tension in TBD wire is 294.3. So this is the solution of this particular problem. I hope you people would have understood this solution. Kindly like all my videos so that YouTube can promote my channel.